As it said on the previous page in the introduction, the chi-square test of independence is one of the different types of chi-squared tests. It's the only one we'll go over in this class, but it's supposed to be a new test to test a claim about the relationship between two categorical variables. That's what the previous page had said. In this unit, we learn to conduct the chi-square test. Yeah, and like it says here, chi, it looks like a CHI, so you think you would say chai or chi or something, but it's actually like chi. So it almost looks more like, or it sounds more like K-I-E, kai, It rhymes, like it said, it rhymes with sky. This test examines the relationship between two categorical variables to determine if they're independent. So, for example, smoking cigarettes and blood pressure, maybe there's a claim that someone makes about one affecting the other. Well, if you smoke cigarettes, then your blood pressure goes up. This would be something like that. Maybe that if there's a way to measure those two things with a categorical variable, we could test if those two things are independent of each other, so they have nothing to do with each other and don't affect each other, or if there's actually a relationship between the two. And then a bunch of other examples we'll see on this page and the coming pages. Previously, in checking conditions for the ANOVA test, we learned the term independent samples to indicate that the outcomes of one sample do not affect the outcomes of the other. For example, for a random sample of college students, the hours of television viewing by males is independent of television viewing by females. However, for random samples of heterosexual married couples, hours of television viewed by males is not independent of television viewing by females because husbands and wives are likely to influence each other's television viewing. By contrast, we are now trying to determine if one categorical variable is independent of the other in a population. Here, independent means that there is no relationship between the two variables. If there is a relationship between the two variables in the population, then they are dependent. We can answer the following research questions with the chi-square test of independence. One, for example, would be, for young adults in the United States, is gender related to body image? Another might be, is alcohol abuse by New York firefighters dependent on participation in the 9/11 rescue operation? A third example could be, in the United States, is race associated with political views? Conservative, moderate, liberal? The null hypothesis would say, in essence, that there is no relationship between the two variables in the population. In other words, the variables are independent. The null hypothesis would say that. The alternative hypothesis would say that the two categorical variables are related in the population. In other words, the variables are dependent on each other. To test our hypotheses, we select a random sample from the population and gather data on two categorical variables from each individual. Usually, we identify one variable as the explanatory variable and the other variable as the response variable. Both variables can have multiple values. For example, the explanatory variable might be gender, 2 values, male or female, or college class, which is 4 values, freshman, sophomore, junior, senior. Similarly, the response variable can have multiple values. For example, the response variable might be pet ownership, 2 values, yes or no. Yes, I do own a pet, or no, I don't own a pet. Or employment status, 3 values, unemployed, employed part-time, employed full-time. So those would all be categorical because you cannot measure them with numbers. You measure them with a category or a phrase or word. Here's another example that talks about gender and body type. Or sorry, not gender and body type, gender and body image. What is your perception of your own body? Do you feel that you are overweight, underweight, or about right? A random sample of 1,200 US college students answered this question as part of a larger study. The following table shows part of the responses. I think we saw the study in a previous module quite a while back. This is only part of the responses. We're only looking at student 25, 26, 27, 28, 29. That's only 5 people. But I think there were more in the original study. And then the second column says what gender they were, M for male, F for female. And then the third column is, how do you feel that your body image looks? Is it overweight, about right, or underweight? So they have them all listed there, at least for these 5 people. Okay. Notice that the sample is a random sample from a single population, US college students. Notice also that we collected data on 2 categorical variables for each student, gender, the explanatory variable, and body image, the response variable. We think that your gender would affect whether you would say you're overweight, underweight, or about right. This is the type of situation that is appropriate for chi-square tests of independence. The first step, kind of like we've done before, would be state the hypotheses, the alternative and the null. Here are the 2 equivalent ways we can state the hypotheses for a test of independence. First, the null hypothesis is there is no relationship between gender and body image for US college students, but the alternative hypothesis would say that there is a relationship between them. We're not going to specify what it is. If it's females or males are more likely to feel that their body image is one or another. We just have to say that they are related. That's enough for the alternative hypothesis. But we could also restate the hypotheses this way, listed here. First, that the null hypothesis could say gender and body image are independent in the population of US college students. The alternative hypothesis could say gender and body image are dependent in the population of college students. So either way we define them, they both mean the same thing. Step 2 would be collect and analyze the data. We summarize the data for this sample in a two-way table. The observed counts come from this sample. So this is the total number. I think we saw this back when we first looked at two-way tables. For females, which is the first row, we have columns that the first column talks about whether you feel like your body image is about right. The next one's how many of them said underweight, how many said overweight, and then the total number of females that were polled here, 760. And then same for males and then second row. The first number on the leftmost number is the number that thought they were about right in body image. The next is overweight, and then the following is underweight. And then a total of 440 males were polled. And then column total, so there were 1,200 total students that were polled altogether. 110 of them thought they were underweight. That's male and female put together. Overweight, 235 people in college thought that was their category, and 855 thought they were about right. Okay. To investigate the relationship between gender and body image, we start by examining the distribution of body image, the response variable, without regard to gender, the explanatory variable. This gives us a baseline for comparison. So we'll kind of know whether you're male or female, any gender, what the average body image is. How many people overall total think that they're overweight or underweight, what percentage, what proportion. Then we'll add the explanatory variable gender into the mix. We compare the baseline distribution of body image, that's just body image for everybody, male and female, all put together. And then we'll compare that to the response variable. We'll separate the males and the females and see if there's some kind of relationship between them. The table below shows what we mean by distribution when we talk about categorical variables. So let's look at that now. So it has these conditional percentages. It's just kind of created proportions and percentages out of these. So for example, the very top left box here, it's the number of females who felt that their body image was about right. It was 560 out of 760 total females. 73.68% of females said that's how they felt about their body. And then 21%, because there were 163 of the 760 females, 21% thought that they were overweight. And then finally for females, 4.87% thought they were underweight, 37 out of 760. And of course, those percentages should pretty much add up to 100% or close to it, because these percentages were probably rounded. So maybe it won't add up to exactly 100, but if it's close, it's 99 point something or 100 point something. And then the same thing for the males. We have percentages. 67% of males thought they were about right. 16% thought that they were overweight. A little bit over 16.5% thought they were underweight. And those should all basically add up to 100 or close to it. And then we have the totals. So for males and females, 71% thought they were about right for body image. And then about 19.5% thought that they were overweight. And then 9.25, a little less, just over 9% thought they were underweight. And all those should add up to 100. So it's the top row represents females, proportions of females. How many of the females thought they were about right, overweight, underweight. Second row represents males. And the last one represents just all the students together, what percentage. The baseline is the bottom row. We simply calculate the percentage of the sample with each response. Therefore, we calculate each percentage using the total sample size. The baseline ignores the effect of the explanatory variable. The rows going across represent the groups defined by the explanatory variable. Here, the explanatory variable is gender, so we have a row for females and a row for males. The percentages across a row are conditional percentages. Therefore, we calculate each percentage in a row using the total number in that group. So it's not the total number of students, 1,200. I would calculate all the proportions in the row for females just based on the denominator of 760, the number of females, not 1,200, the number of people in general. And then same thing for males. There were 440 males, which is why all the denominators in the male row were 440 and not 1200, the total number. The row percentages represent the effect of the explanatory variable on the response variable. We graph these conditional percentages using ribbon charts for a visual comparison. Let's look at those now. So ribbon charts, these are kind of nice. It's just one whole graph like this one represents males. It kind of shows you what proportion, just literally you could see the colors, what proportion of them think they're about right. So the green represents about right. And I think the purple pinkish color represents those who think they're overweight, and the yellow represents those who think they're underweight. So you can tell that the totals, the numbers are kind of between males and females. You can see the females not a whole lot of yellow, males quite a bit more yellow, less pinkish purple, and maybe the males too a little less green than the females. But the overall here, this is just everybody, college students in general. I'd say the yellow portion is probably between the size of the female and male yellow portion, and the pink kind of a similar thing, but they're all around the same size, and as far as the colors go. In this sample, we can see that about 71.3% of the sample perceive their body weight to be about right, but a larger percentage of females, 73.7%, and a smaller percentage of males perceive their body weight to be about right. About 19.6% of the sample feel they are overweight compared to a larger percentage of females, 21.4%, and a smaller percentage of males, 16.4%. So I guess we'd be interested in, does that difference, overall, what was it, 19.6% of students overall feel that they are overweight, and then compared to just females, 21.4% believe they're overweight. So is that percentage big enough of a difference? That's not quite 2% difference, it's 1.8% difference. Does that mean there is a correlation, or is that just random chance, or something like that? I guess that's what the chi-square test is going to tell us. About 9.2% of the sample feel they're underweight. Males are more likely to view themselves as underweight, 16.6%. But females as much less likely to perceive the weight this way, 4.9%. For easier comparison, below is the table with just the percentages shown. Instead of the table above that had the proportions and then the percentages, let's just look at the percentages for each response variable category: underweight, overweight, about right. In other words, the percentages in each column going down in this table should be the same. Let's see. We'll scroll down and look at that now. Okay. So it's the same. Yeah, this table is the same as it was above, the table that was above the graph, the ribbon graph, but this time we don't have the proportions inside the boxes, just the percentages. So obviously when we compare the conditional percentages for females and males in this sample, we see that they differ. But like we're kind of questioning, do they differ enough to conclude that variables are independent? Or could these differences be the result of chance fluctuation that happens when sampling from a population where gender and body image are independent? We need to conduct a chi-square test of independence to find out.